Hello guys, this is Himanshu from Code Campaign and we are continuing with our binary tree module. So in binary tree module, we left our video last time at the binary tree traversal. So we discussed in the last video the pre-order traversal, in-order traversal and the post-order traversal code. So today we are going to discuss about the code of the level order traversal. So let's recap on the level order traversal once again. So what is level order traversal? Let me just change the ink color. Okay, so let's draw one binary tree. Okay, suppose this is our binary tree. Now what we have to do, the level order traversal on this tree. So what level order traversal says that we have to traverse all the node which belong to a particular level. So what are the different level in this tree? So we have to just cut the tree with a horizontal line, right? So this node will be on the first level or zeroth level. So we'll say this node is on the first level. This node will be on the second level. These nodes will be on the third level, and these nodes will be on the fourth level. So this tree has four levels, right? And so what we have to do in level order traversal, we have to print all the nodes which belong to a particular level. So what will be the level order traversal for this tree? It will be 1. Then on this second level we have 2 and 3. Then on the third level we have 4, 5 and 6, and then on the fourth level we have, oh sorry, here we have 4, 5 and 8, and on the fourth level we have 6, 7 and 9. So this is our level order traversal, right? Level order traversal. This is our level order traversal. So okay, so now let's go ahead and write the code for this level order traversal. Okay. Okay, so again we are in our Visual Studio ID. This is where we left our Visual Studio ID. So okay, let's go ahead and start writing our level order traversal function. Let's name it level order traversal. Okay, again we'll get the root node as an argument. First we'll check if root is null. If root is null, then there is nothing to explore, so we'll just simply return very basic stuff. Now okay, so now let's go back to our slide, and yeah, this was our slide, right? So let's discuss how we can actually print the nodes on the level, right? So we are given this level. Let me again change the color. Cool. So make it white. Okay, so we are given this root node, right? And what we had to do, we have to print all the nodes at each and every level, right? So what we have to do here, we have to actually what we have to do, we have to actually store the children's if they are existing. So suppose I am at node 1. So what I have to do, I have to somehow store the children's of this first node, right? So that later I will be able to explore these children's, right? And in which order I have to store these children? First, I have to store the left children, and then I have to store the right children there, because that's how we are printing here, right? We are going from this direction to this direction. So first we have to store the left children, and then we have to store the right children. Okay, so okay, this is fine. And here in this case again, we will store all the childrens, right? So we will store the childrens of 2, and then we'll store the children of 3, which is only 8, right? So what data structure actually we have to use here? So if you look closely, what are we doing? Whatever node we are inserting first, we have to take that node out from our data structure, and then we have to store their children. So suppose I am, let's take the example, suppose I am storing node 2 first, and then I am storing node 3. So actually I have to, what I have to do, I have to explore, after this I have to explore the children of node 4 and 5, right? So what I will do, I'll just store the childrens of node 2, which are 4 and 5. So actually order I have to maintain in which I am traversing, right? I have to maintain the order. So if you look very closely, actually this property will be satisfied by Q. So if we use Q, which is first in, first out data structure, we can actually achieve this. Let's see how. So suppose we are on this node. So we stored 1 here in this, right? Now what we'll do, we'll take out 1 from here and we'll put its children inside the queue. So first we'll take out 1 from here, so our queue will be empty, and then we'll put 2 and 3. So first we'll put 2 and then we'll put 3, left and right children into this. Okay, now after this what we'll do, we'll take again the element which is at the start of the queue, or which is at the front of the queue, which is 2. So we'll take 2 out and we'll put the childrens of the 2 into the queue, right? So 3 will be there, and then we'll put the children of 2, which are 4 and 5, right? Then again in the next step, and we'll and what we'll do, we'll keep on printing the elements which we are taking out, right? So suppose here we are putting our output. So first what we did, we took out the 1, so we'll print 1. In the second case we took out the 2, so we'll print 2. Now our queue state is this, right? So this is our queue. Now what we'll do, we'll take out the 3, right? So our uh, so let me erase, what should I do? Okay, let me put our queue here. So we'll took out the 3, so 4 and 5 will be left here, right? Now we'll print 3 and we'll insert the children of 3 into the queue, which is 8, right? We don't have any left children for 3, only 8 is there. Okay, now what we'll do, we will take out again the front element, which is 4. So we'll take out 4. So 4, we took out 4, right? We took out 4, we'll print 4 and we'll insert the children of 4 into the queue, which is only 6. So we'll insert 6. Then next, again what we'll do, we'll take out the first element, which is 5. We'll print 5 and we'll insert the children of the 5 into the queue, which is 7. Then we'll take again the front element, which is 8. We'll print 8 and then we'll insert the children of 8, which is only the right children is there, so we'll put 9. Then again we will take the element which is at the front of the queue, which is 6, and 6 do not have any children, so we'll not put anything here. Then we'll take the next element which is at the front, which is 7, and 7 also do not have any children, so we'll not put anything here. Then we'll take the last element, which is 9. Now our queue is empty, so we'll end our program. So this is your level order traversal, right? So what data structure we use? Queue. And why we used it? Because we had to maintain the order in which we were inserting the element, and we needed something to store the childrens of a particular node which we are exploring, right? So we had to have a uh, uh, data structure in which we wanted to store the elements and we wanted to maintain the order also. Like we wanted to took out the element which we inserted at first, right? Whatever we inserted first, we wanted to take it out first. So that's why we use queue. Okay, so let's go ahead and write our program now. Okay, so we are back into the ID. So what we have to do, we have to use the queue. So I'm taking normal list. So I'll use list as a queue. Okay, let's name it queue. Cool. So now we have the queue. So let's insert our root element into the queue. Now what we have to do, until our queue is empty, we have to keep on taking the elements out of the queue, right? So queue count is uh, greater than 0. We have to keep on taking out the element of the root. Okay, so now we'll take and one more thing what we have to do here, let's go back to over here, right? What we have to do, uh, we have to print all the elements which are belong to which are belong to a certain level, right? So we have to explore. So for one, there was on the level 1 there was only one element, but on the level 2 there were two elements, right? So we had to explore these two at once, right? So let's see what we can do for this. What we'll do here, we'll take one count integer. So this count integer will tell us at this moment or at this level how many elements are there into the queue, right? So until the count is greater than 0, we will run this loop. So this is the number of the children's. So for so initially there will be only one element, which is 1, but when we'll come on the next level, there will be two elements into the queue. Okay, we'll run the program so it will be more clear. So now what we can do, let's take out the element which is at the front of the queue. Let's say it as node. So let's take out the element at. So front of the queue will be the 0th index. So we are taking out the element which is present at the 0th index. Now we have to remove that element. So we'll remove that element. Okay, and we'll print that element also, right? Because whenever we were taking out the element, if you remember the example, we were printing the value of the element. So we'll just print out the value of the element. Okay, printed the value of the element here. Now what we'll do, we have to insert the children's of this element into the queue. So let's check if this node element whatever we have has the left child. So if left is not equal to, that means it has the left child. So we'll insert this left element into our left child into our queue, right? So we'll say add, and we will just insert the left children to the queue. Now we'll again check for the right child also. If right child is also not equal to null, and if right child is also there, we'll insert it into the queue. We're inserting the right child into the queue. So now we have inserted the left child and the right child into the queue. So we will just decrement the count, right? And just to print all the elements on a particular level, let's insert one new line here. So this will make our output more clear to us. Cool. Okay, so yeah, that's all. So this program will go ahead and print the elements which are elements into the level order and which are present to the tree. Okay, so now let's go ahead and run this program. So okay, let's create one more tree which we took in our example. So let's create one more tree and let's say so okay, and I don't remember what was the example, so let's go back and check. 1 2 3. Okay, so let's 1 2 and 3. Let's create one, and root 2 left was 2. Let's put 2 here, and root 2 right was 3. Okay, now let's go back here. Root 2, okay, left, the root left was 4 and left right was 5. Okay, oh, so left was 4, and left right was 5. Cool. And root 2 right was 8. Okay, then root 2 left was, and this I forgot, I need to check again, so let's go back to this line. Left was 6 and left right was 7. 6 left right was 7. Let's go back to the last one. Ra right is 9. Right 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 is 9. Okay, that's cool. So now let's use our traversal util and call our level order traversal and check if this thing works or not. Let me comment the previous code to avoid the confusion. So I have to comment till here. Cool, so let's run it. Think something bad happened here. Let's go back and debug what happened. So left left right. Okay, let's go into our implementation and let's see once again what is happening here. So we inserted the root. Okay, count. Okay, so here it is the problem. We have to take the count of the array rather than taking it as a 0, right? Okay, so now let's run it again. Okay, everything is being printed as 1, so there is some other problem. Okay, yeah, this should be node. This time hopefully it should work. Okay, so let's match this output with the output that we had. Okay, so on the first level we have 1, on the second level we have 2, 3, third level we have 4, 5 and 8, and fourth level we have 6, 7 and 9. So this output looks fine. Okay, so yeah, that's all for this video. Let's go ahead and check in our code as well. So let's check in our code. Yeah, so these are the files. That oh, should we just commit? Okay, so now let's push it to our remote branch. I don't know why it's stuck. Let's okay, so we pushed it to our remote branch. So that's all for this video. If you haven't subscribed to my channel, just go ahead and subscribe. Please like the video if you like it, and comment, put if you have any confusion in the comment box. I will try to reply. Thank you.